Hi guys, good day to you. This is another moment with your favorite host, Mrs. Sawakong and Mathematics Appreciation. Today we'll be talking on dummy regression analysis. Dummy regression analysis is a regression analysis suitable for modeling the relationship between a quantitative dependent variable and a qualitative or categorical variable. So in this case now, it means that the independent variable will be categorical in nature, will be of levels, but the dependent variable will be a quantitative or numerical variable. We have example here on the board. We say fit a regression model to the data below and interpret your result. So if you can look at the example, the question, nobody mentions dummy regression because it is expected of the problem solver to know the kind of regression model to apply when we are given this kind of problem. Here we have weight, and here we have gender. So it is expected that weight depends on gender. That means weight is the dependent variable and gender is the independent variable. So we have about a sample of 1, 2, 3, 4, 5, 6. Okay, we have weight in kg, 21 kg was a female, 72 kg was a male, 14 kg was a male, 34 kg female, 55 kg a male, 37 kg a female. So now how can we predict the weight of any particular respondent here based on the gender? If you look at the gender here, we don't have any numerical value here. We have a categorical variable here, categorized into male and female. So for us to be able to fit a regression model to this particular data set, we need to first of all code the data set because there's no way we can compute with this information here if you don't code it into something that is interpretable. So solution, we say, firstly, we need to code the data for analysis. And here we say that we code female to be 1 and male to be 0. The other way could still work. We can code male to be 1 and 0 to be female. Whichever way, the result will be the same. But we have to know how to interpret the result based on how we coded the data. So to code the data now, we have weight, the same thing we had before in the original data set. And we now code the gender, 1 for male, 0 for 1 for female rather, 0 for male, 0 for male, 1 for female, 0 for male, and 1 for female. At this point now we have numerical representative or stand-ins for the categorical variable we have under gender. With this now we'll be able to solve and interpret our result. So using the same simple linear approach, simple linear regression approach, we now put a table of 4 columns here for the dependent variable y, which is weight in kg, and here for the independent variable x, that's gender. This column is for the product of weight and gender, and this one is the gender squared. So the same way we normally fit a simple linear regression model, we take the sum of each of the column. We say sum of y column, that's the weight is 233, sum of x column is 3, sum of xy is 71, and sum of x squared is 3. So we now substitute these values into the formula for b, which is b equals n times sum of xy minus sum of x times sum of y all over n times sum of x squared minus sum of x all squared. Y, of course, n here in this case, from here to here, is just 6. N equal to 6. That's the number of samples we use for this particular analysis. All divided by n times sum of x squared minus sum of x all squared. So if we put this in, we do the simple arithmetic, we have 426 minus 699 all over 18 minus 9. And that results to 30.33. At that point, we simplify it into 54.0. Sorry, B here is minus 30.33. If we do the simple arithmetic for A, which is part of the model, we have A to be 54.0. And this now becomes a fitted model. a fitted model. So if we have this now, how do we interpret, how do we make sense of this model now? Okay, now we go to interpretation. And here we say that the regression constants here, which is 54A, implies that the average weight of the people in the group, irrespective of gender, is 54 kg. So no matter the gender here, the average weight of any person picked from here will be 54. That is the meaning of this particular regression constant. Regardless of gender, if you pick any person here, assuming we don't consider the gender, so the weight will be 54 kg. So this particular side B, which is minus 30.33, here implies that a female in this group weighs 30.33 less of male's weight on the average. That means if we pick any female here, on the average, the person will weigh 30.33 kg, less than that of a man's weight here. So with this, we've been able to fit a dummy regression model by first of all coding for the categorical variable here with zeros and ones, where dummy means number that is 0 and 1. And we've been able to use that information to present this analysis and have a fitted model. And we've given the interpretation of the model as this, that the man's is weightier than a woman by 30.33 kg. And on the average, irrespective of the gender of any person picked here, the average weight will be 54 kg. I appreciate you for watching this video up to this time. I really thank you. Please do well to subscribe to our channel, share this content, like, and comment on the aspects you want us to improve or anything